All right, today we're going to get started on section 9.6. So this will be the last section for the chapter that we're going to worry about. Again, we're going to skip section 9.7. So we're going to finish off with this one. And the idea here is that we're going to look at how to solve triangles when we're given, instead of two angles and a side, instead what we're going to be given this time is two sides and one angle. Okay, now to get there, to be able to solve triangles when we're given two sides and one angle, we need to go back to a basic idea of algebra, and that is to solve equations we need to use inverses. All right, as an example, if you have an equation with addition in it and you want to get rid of addition, you do the inverse, which is subtraction. You know that adding and subtracting the same number cancel each other out, so those are inverses of each other. Multiplying and dividing, same thing. Multiply and divide by the same number cancels each other out. When you square something and when you take the square root of something, those two things cancel each other out. So we're going to use inverses to solve triangles when we're given two sides and an angle. It's just that we're going to use a different type of inverse. All right, instead of adding and subtracting, instead of multiplying and dividing, instead of squaring and taking square roots, we're just going to use different types of inverses. Okay, and let me show you how it works. All right, so I'm going to give you a triangle. And let me draw a decent triangle out here. So we're going to give you a triangle that looks like that. And the information we're going to put in the triangle is that one of the angles is 90 degrees. And then we're going to tell you two out of the three sides. So as an example, maybe we'd say that this side is 8 units long, and maybe this side over here is 20 units long. And if I put some letters on this picture so we have something to reference. So what we'd be given in this picture is side 8, side 20, and angle A is 90 degrees. So it'd be given two sides and an angle. So what we're missing, what we're going to be trying to find, are angles B, angle C, and also side B. So those are the three missing pieces. Okay? So when we're given two sides and an angle, how do we find the missing pieces? Well, one of them is relatively simple. One should be relatively simple, and that is the third side. In this case, little b. And why should that be easy? Well, it should be easy because we know two out of the three sides of a right triangle, and we know whenever we have two out of the three sides, we can use Pythagorean theorem to get the third side. So I'm just going to remind everybody, the side directly across from the 90-degree angle is the hypotenuse. So that means the 8 is a leg and the b is a leg. So Pythagorean theorem would then be 8 squared plus b squared, and that's always got to be equal to the hypotenuse squared. So we just dig out our calculators. 8 squared is 64. 20 squared is 400. We move positive 64 to the other side by subtraction. So b squared is going to be equal to 336. And we get rid of the power of 2 by taking the square root, again, inverses. And so what we're going to be left with then is b is equal to the square root of 336, which is approximately 18.3. Okay, so there's one of our three missing pieces. Okay, and no trig involved, just Pythagorean theorem. Okay. So that shouldn't be too bad. Now things get a little bit friskier because now we want to find one of the missing angles. All right? We have to make a choice. Which angle do we want to find first? And just for the heck of it, I'm going to go alphabetical. So I'm going to find angle B first. So I'm going to put a big box around that just so we remember that's the one we're trying to find. And now what I need to do is label the other two sides of the triangle. So the side directly across from the angle we're looking for is called the opposite side. And the side that makes up the angle that's not the hypotenuse is called the adjacent side. All right? And now what you need to do is pick the trig function that involves the two sides we know the length of. So we know the adjacent side is 8 and the hypotenuse is 20. The adjacent side is 8, the hypotenuse is 20. And which trig ratio involves adjacent and hypotenuse? Which one? Adjacent hypotenuse is cosine. So we use the cosine of angle B, and what cosine is equal to then is the adjacent side divided by the hypotenuse. Our adjacent side is 8, and our hypotenuse is 20. Once again, we've created a trig equation. It has a trig ratio, cosine, and it's an equation that we want to solve. But what are we trying to solve for this time? We're trying to solve for angle B. That's what we're trying to get by itself. Now, if we had a number added to B, we would do subtraction because adding and subtracting are inverses. If we had a number multiplied by B, we would do division because multiplying and dividing are inverses of each other. But what's attached to the cosine isn't addition, it's not subtraction, it's not multiplying, it's not dividing, it's not a power, but it's a trig function. So what do we do to get rid of a trig function? And the answer is we do the inverse of that. All right, we do the inverse of a cosine. And what is the inverse of a cosine? Well, it's not very imaginative, but what we call it is the inverse cosine. And the notation we use for it is we use the trig name, so cosine, and then we use a little -1 superscript to indicate inverse, okay? And whatever you do on one side, just like addition, just like subtraction, just like multiplying, just like dividing, whatever you do on one side, you have to do the same on the other side. So if we take the inverse cosine of the left side, we have to take the inverse cosine of the right side. Okay, so let's go ahead and do it. Let's take the inverse cosine of the left. So what we end up with is the inverse cosine of the cosine of B. And on the right-hand side, we have the inverse cosine of 8/20. Okay, now what happens on the left side, let me scooch over to the side for just a second, would be the same thing that would happen if we had x plus 5 is equal to 11 and we wanted to move plus 5 to the other side by subtraction. What happens with the plus 5 and the minus 5? Whoop, they cancel each other out. What if we had an equation with multiplication? We had 3 times m is equal to 21, and we did the inverse, which is division. What happens with multiplying 3 and dividing 3? Whoop, they cancel each other out, and we're left with m equals 7. So back to our problem. What happens when we take the inverse cosine and the cosine? Since they're inverses of each other, they whoop, whoop, cancel each other out, and we're just left with angle B. Okay? Now on the other side, we have this weird looking thing that out loud we would read as inverse cosine. The little -1 is read as inverse. So it'd be the inverse cosine of 8/20. Okay, you're thinking, what in the world am I supposed to do with that? But luckily our calculators all have inverse trig functions available to them. All right, so wherever you have your cosine key, right above it is going to be an inverse cosine key. So what we do is we just simply turn our calculators on and we enter inverse cosine. For most of us, we have to touch the second button. So second cosine. And what should come up on your calculator is a cosine with a little -1 above. And we just simply enter 8 divided by 20. And when we hit the equal sign, we get the angle 66.4 degrees. All right, and so we found our second missing piece. All right, so we only have one left. That's angle C. We could go through this whole inverse trig function stuff again, or we could just remember that the three angles add up to 180 degrees. So if we subtract away angle A, the 90, if we subtract away angle B, the 66.4, whatever is left over then has to be angle C, because they again have to add up to 180. And what we get when we do that subtraction is 23 9.6 degrees. Okay? And that's how we can then solve a triangle, when we're given two sides and one angle. When we're given two sides and one angle. Okay? Alrighty. So feel free to pause this as long as you'd like to jot anything down in your notebook that you need so that we have it for the future. But I just want to kind of highlight that. So if we have a problem with a sign and we want to get rid of the sign, we're going to take the inverse sign. So it's going to be the sign with the little -1 superscript. If we, as we just saw, if we have a cosine in an equation and we want to get rid of it, we take the inverse cosine. And of course, no surprise, if we have a tangent in an equation and we want to get rid of it, we take the inverse tangent. So these again are the inverses of the regular trig functions. These are the inverses of sine, cosine, and tangent. All right? And the idea again is that the inverse sine and the sine of whatever are going to cancel each other out, just giving you whatever's left attached. Okay, as you saw in the previous one, inverse cosine of the cosine, boop, cancel, and same thing's true, of course, of tangent. If we have an inverse tangent and a tangent of something, those two things are going to cancel each other, and we're just going to be left with whatever's attached. Usually it's a variable, of course, but we're just left with what's attached. Okay? All right, so let me give you another example of how to use the inverse trig functions to solve a triangle. So once again, let me throw a triangle up here. Let's get one this way. And I'm just going to spin this, oop, that didn't work. I'm going to spin this around just to make it look a little different so we get a different view. Yeah, that works just fine. Okay, and once again, we're going to be given three pieces of information. We're going to be given one angle, and we're going to be given two sides. So let's say this side is 18, and this side is 8. And let's put some labels on these angles so we have something to work with. Let's go with P, Q, and R this time. Okay, so here we're given one angle and two sides. Angle is R, 90 degrees. One side is 8, the other side is 18. So what we're looking for then is side R, little r, and then we're looking for angle P, and we're looking for angle Q. Again, one of those isn't going to be too bad. The side R shouldn't be too difficult because we know 2 out of the 3 sides, so we can use Pythagorean theorem. So the side directly across from the 90-degree angle is the hypotenuse, right? And therefore 8 is a leg, 18 is a leg, and so Pythagorean theorem is going to be leg squared plus leg squared is equal to hypotenuse squared. 8 times 8 is 64. 18 squared is 324. When I add those together, I get 388. And to get rid of the power of 2, we do the inverse. So we take the square root of both sides. So r is going to be the square root of 388, which is approximately 19.7. So there's our first missing piece. Remember, we're trying to solve for all of the missing pieces. There's our first. Okay? Now, to find the missing angles, we have to pick one to start with, and just for the heck of it, I'm going to go with I'm going to go with P. I was boxing in the wrong one, said the other. Okay, so I'm going to find angle P, and to accomplish that, I need to label the other 2 sides. So the side that's directly across from P is called the opposite side. And then the side that makes up P that's not the hypotenuse is called the adjacent side. So what we have to do is decide for ourselves which trig function to use, all right? And to find an angle, we have to pick the 2 sides we know. Okay, in this case, we know the opposite and we know the adjacent. Which trig function goes along with or pairs opposite and adjacent. Only one of them, and that one is tangent. So we write down the tangent of capital P, and what that's going to be equal to, our tangent is always equal to the opposite side, 8, divided by the adjacent side, 18. Okay, there's our trig equation. And once again, let me choose a different color here just so I can highlight it. The variable is P. The variable is angle P. So what we're going to do is solve for that. And to solve for that, we have to get rid of what's attached. And what's attached to capital P is tangent, right? And how do we get rid of a tangent? We do the inverse. And so therefore we take the inverse tangent of the left-hand side, and whatever you do on the left-hand side, you also have to do the same thing on the right-hand side. Whatever you do on one side, you got to do on the other. So just like I wrote on the previous screen, inverse tangent and tangent, hey, those are inverses of each other. So it's like multiplying and dividing by 4, adding and subtracting 11. They cancel each other out. And what we're left with then is P is equal to the inverse tangent of 8 over 18. And that becomes our calculator problem. So again, you have to turn your calculator on, find the inverse tangent key, inverse tangent key. Most of us have to hit the second button, so second tangent. And what you should see on the window is tangent with a little -1 superscript. And then we put in 8 divided by 18. And the angle we get out is approximately, about 23.9. It's about 23.9 degrees. And there's our second missing piece. Okay, now to find angle Q, we could just keep doing the inverse trig stuff that we just did. Or, remember that the 3 angles add up to 180. So if I subtract away the 2 that I know, I've got to be left over with, what's left over has to be the third angle. So what we're left with then, guys, is, and that's going to be about 66.1 degrees. And we have our 3 missing pieces. We started with 3, we found 3. We know every angle, we know every side of the triangle. Okay? So that should get you, that should get you a pretty decent start on section 6. I just want you to shut down the video and then get started and try some of your own. Try some of your own. So try some of the problems in the assignment and see if you can start to figure them out. I'll be back right away tomorrow to help you with anything else that you might be confused on, and we'll finish off the rest of the chapter then. Okay? So hope you're having a good day, and we'll see you tomorrow.